Use AI visuals such as decomposition trees, Q&A visual, and key influencers to find insights. Deep dive tutorial. Use AI visuals such as decomposition trees, Q&A visual, and key influencers to find insights in Power BI. AI visuals in Power BI, such as decomposition trees, Q&A visual, and key influencers, are powerful tools that help uncover insights automatically without needing complex manual analysis. These AI-driven visuals enable users to explore data, ask natural language questions, and identify key drivers behind performance metrics. This tutorial will guide you through how to implement and leverage these AI visuals effectively to discover trends, anomalies, and drivers behind your data. 1. Using decomposition trees to break down metrics. 1.1. What is a decomposition tree? The decomposition tree in Power BI is a visual that breaks down a metric into its contributing factors, enabling users to explore and analyze data hierarchically. It helps you understand how different dimensions such as region, product, or category contribute to a metric like total sales, profit, or customer satisfaction. 1.2. Common use cases for decomposition trees. Sales analysis. Break down total sales by regions, product categories, or sales channels to understand which factors drive the overall number. Profit analysis. Analyze profit margin by product lines, regions, or salespersons to uncover trends or issues. Operational metrics. Break down customer satisfaction scores by region, service type, or agent to find areas for improvement. 2. Steps to create a decomposition tree. Step 1. Add the decomposition tree visual. 1. In Power BI Desktop, navigate to the report page where you want to add the decomposition tree. 2. Select the decomposition tree visual from the Visualizations pane. Step 2. Set the metric to analyze. 1. Drag the metric you want to analyze, for example, total sales, profit, revenue, into the Analyze field of the decomposition tree. This metric represents the value you are trying to break down. Step 3. Define the dimensions for decomposition. 1. Drag the fields that you want to use for breaking down the metric, for example, region, product category, salesperson, into the Explain by field. 2. Power BI will allow users to click through these dimensions to explore the metric in more detail. Step 4. Explore the decomposition tree. 1. In Report View, you can click on the decomposition tree to break down the metric by the dimensions you specified. Power BI will dynamically update the tree as you click through each level, showing how different factors contribute to the overall metric. Example: you create a decomposition tree for total sales with dimensions such as region, product category, and sales channel. Users can click through the tree to see which regions or product categories are contributing the most to overall sales. 3. Leveraging the Q&A visual for natural language queries. 3.1. What is the Q&A visual? The Q&A visual in Power BI allows users to ask questions in natural language and get answers in the form of visuals. It leverages natural language processing (NLP) to interpret user queries and display the results in charts, tables, or other visuals. This makes it easy for non-technical users to explore data without needing to write DAX queries or manually create visuals. 3.2. Common use cases for the Q&A visual. Ad hoc analysis. Quickly ask questions like, what are the total sales for the last month? Or which product category has the highest profit? And get instant answers. Self-service reporting. Allow stakeholders to explore the data by asking their own questions without relying on pre-built visuals. Exploratory data analysis. Use the Q&A visual to uncover trends and insights by experimenting with different questions. 4. Steps to use the Q&A visual. Step 1. Add the Q&A visual. 1. In Power BI Desktop, go to the report page where you want to add the Q&A visual. 2. Select the Q&A visual from the Visualizations pane. Step 2. Ask a question. 1. In the Q&A box, type a natural language question, for example, what were the total sales last year? Or show me sales by region. 2. Power BI will generate a visual based on your question, such as a bar chart, line chart, or table. Step 3. Customize the visual. 1. After Power BI generates the visual, you can convert it into a standard visual, for example, bar chart or pie chart, by selecting the Convert button. This allows you to further customize it, just like any other Power BI visual. 2. If needed, you can refine the question to improve the accuracy of the answer. Example, you type the question, what are the total sales by product category this year? Into the Q&A visual. Power BI responds by creating a bar chart showing sales for each product category. 4.2. Best practices for using the Q&A visual. Teach Power BI. If the Q&A visual doesn't recognize certain terms, you can teach it by adding synonyms or defining custom terms in your dataset. This helps users ask questions in their own language. Keep questions simple. Encourage users to ask straightforward questions, such as, what is the profit for Q2? Or show total sales by region. Use for self-service analytics. The Q&A visual is perfect for dashboards that allow users to explore the data on their own without needing pre-built visuals. 5. Uncovering insights with the Key Influencers visual. 5.1. What is the Key Influencers visual? The Key Influencers visual in Power BI helps you identify the factors that drive or influence a specific outcome. It uses machine learning algorithms to analyze your data and highlight which fields or variables have the most significant impact on a given metric. 5.2. Common use cases for the Key Influencers visual. Sales drivers. Determine which factors, for example, region, product type, marketing campaign, influence sales growth the most. Customer satisfaction. Uncover which variables, for example, customer demographics, product usage, service type, have the most impact on customer satisfaction. Churn analysis. Identify what influences customer churn in your business, such as contract length, usage frequency, or support interactions. 6. Steps to create a Key Influencers visual. Step 1. Add the Key Influencers visual. 1. In Power BI Desktop, go to the report page where you want to add the Key Influencers visual. 2. Select the Key Influencers visual from the Visualizations pane. Step 2. Define the metric to analyze. 1. Drag the field that represents the outcome you want to explain, for example, total sales, customer satisfaction, profit margin, into the Analyze field. This is the metric Power BI will analyze to find what factors influence it. Step 3. Add dimensions for explanation. 1. Drag fields that you think might influence the metric, for example, region, product type, customer segment, into the Explain by field. 2. Power BI will analyze these fields to determine which ones have the strongest correlation with the outcome. Step 4. Interpret the results. 1. Power BI will display the most influential factors on the left side of the visual, showing which fields have the biggest impact on the outcome. 2. Users can interact with the visual to explore how different factors contribute to changes in the metric. Example, you use the Key Influencers visual to analyze customer satisfaction scores. The visual reveals that customer support response time and product quality are the top 2 factors influencing satisfaction levels. 6.2. Best practices for the Key Influencers visual. Focus on important metrics. Use the Key Influencers visual to analyze metrics that are crucial to your business, such as revenue growth, profit margin, or customer churn. Use for hypothesis testing. The visual is helpful for confirming or disproving assumptions about what drives certain outcomes. For example, if you suspect region influences sales, the Key Influencers visual can confirm whether this is true. Leverage interactive features. Allow users to interact with the visual to explore how different variables affect the outcome. They can click on each influencer to see how changes in the value impact the overall metric. 7. Combining AI visuals for comprehensive insights. 7.1. Using multiple AI visuals together. AI visuals such as the decomposition tree, Q&A visual, and key influencers can be combined in the same report to provide comprehensive insights. Example, in a sales report, use the key influencers visual to identify the main drivers behind sales growth. Use the decomposition tree to break down sales by region, product, or channel. Add the Q&A visual to allow users to ask ad hoc questions, such as what is the sales trend for Q3? 7.2. Best practices for combining AI visuals. Provide a clear exploration path. Ensure that users can easily navigate between different AI visuals, understanding how one insight leads to another. Encourage self-service exploration. The combination of Q&A and key influencers gives users the tools to explore data on their own, helping them uncover insights without needing detailed knowledge of the dataset. Use AI visuals for storytelling. AI visuals can help tell a story around your data, showing not only what happened, but also why it happened. Conclusion: implementing AI visuals like decomposition trees, Q&A visual, and key influencers in Power BI enables you to uncover deep insights from your data without complex manual analysis. These visuals empower users to explore data hierarchically, ask natural language questions, and identify the factors driving key outcomes. By incorporating these advanced AI features into your Power BI reports, you can transform raw data into actionable insights, helping users make more informed decisions based on data-driven evidence. Perform what-if scenario analysis. Deep dive tutorial. Perform what-if scenario analysis in Power BI. What-if scenario analysis in Power BI allows users to explore different hypothetical situations by adjusting variables and immediately seeing how these changes affect key metrics. It is a powerful feature for decision-making, enabling users to simulate various outcomes based on changes in factors like pricing, sales volume, or cost structures. In this tutorial, we will walk through how to set up and use what-if parameters, adjust variables, and visualize different scenarios for better decision-making in Power BI. 1. Understanding what-if scenario analysis. 1.1. What is what-if scenario analysis? What-if scenario analysis in Power BI involves creating what-if parameters that represent variables in your model, for example, pricing, growth rates, discount percentages. By adjusting these parameters, users can see how changes affect the outcome of key metrics, such as revenue, profit, or total sales. 1.2. Common use cases for what-if analysis. Sales forecasting. Simulate how changes in sales volume or average price impact total revenue and profit. Budget planning. Adjust costs and revenue forecasts to see the impact on overall budget performance. Pricing strategy. Explore how different pricing scenarios affect sales and profit margins. 2. Setting up what-if parameters. 2.1. Steps to create what-if parameters. Step 1. Open your Power BI report. 1. In Power BI Desktop, open the report where you want to implement what-if scenario analysis. Step 2. Create a what-if parameter. 1. Go to the Modeling tab in Power BI Desktop. 2. Click New Parameter, What-if Parameter. 3. In the What-if Parameter dialog box, define the following. Name. Give the parameter a name that represents the variable, for example, discount rate, growth percentage. Data type. Choose the appropriate data type, usually decimal number or whole number. Minimum and maximum values. Set the range for your parameter, for example, 0% to 100% for discount rate. Increment. Define the step increment, for example, 0.05 or 5% for discount rate. Default value. Set the default value to be used in the initial scenario. 4. Check the box to add slicer to this page, which will automatically place a slicer on your report to adjust the what-if parameter. Example, you create a discount rate parameter with values ranging from 0% to 50%, with an increment of 5%. This allows you to model different discount scenarios and their impact on revenue. 2.2. How what-if parameters work. When you create a what-if parameter, Power BI automatically generates two elements: a calculated column in the data model that represents the selected parameter value, a slicer for users to adjust the parameter interactively in the report. This parameter can then be used in measures and calculations to simulate various scenarios. 3. Creating measures to model scenarios. 3.1. Using what-if parameters in DAX measures. After creating a what-if parameter, you need to create DAX measures that incorporate the parameter to adjust key metrics like revenue, profit, or costs. Steps to create a measure using what-if parameters. 1. In Power BI Desktop, go to the Modeling tab and click New Measure. 2. Define a measure that uses the what-if parameter to calculate a new outcome based on the scenario. Example: revenue impact of discount rate. You can create a measure to calculate how revenue changes based on the discount rate parameter. Adjusted revenue equals sum sales total sales asterisk 1 discount rate value. This measure will adjust the total sales based on the selected discount rate from the what-if parameter. Example: profit impact of price increase. For a price increase parameter, you can create a measure to calculate the impact on profit. Adjusted profit equals sum sales total sales asterisk 1 plus price increase value sum sales total costs. This measure reflects how changes in pricing affect overall profit. 3.2. Testing scenarios with slicers. With the DAX measure in place, you can use the slicer generated by the what-if parameter to adjust the value dynamically and observe how it changes the results in real time. Example: by adjusting the discount rate slicer, users can see how applying different discount rates, for example, 10%, 20%, or 30%, affects the overall revenue and profit calculations, providing insights into pricing strategies. 4. Visualizing what-if scenarios. 4.1. Display scenario results in visuals. Once you've created measures that depend on what-if parameters, you can display the results in various visuals, such as bar charts, line charts, or tables. This helps users compare the outcomes of different scenarios side by side. Steps to visualize what-if scenarios. 1. Add a visual, for example, bar chart, line chart to your report. 2. Drag the adjusted measure, for example, adjusted revenue or adjusted profit, into the values section of the visual. 3. Use the slicer to adjust the what-if parameter and observe how the visual updates dynamically. Example: in a sales report, you display total revenue and adjusted revenue side by side in a bar chart. As the user adjusts the discount rate, the chart updates to show how different discount rates impact revenue. 4.2. Create scenario comparisons. You can create multiple what-if parameters to compare different scenarios at once. For example, price increase versus cost decrease. Create separate parameters for price increases and cost reductions. Then visualize how each scenario affects profit. High growth versus low growth. Model high growth and low growth scenarios using separate parameters. Then compare the results in a visual. Example: in a profit comparison dashboard, you add slicers for both price increase and cost decrease parameters. Users can adjust each parameter independently to see how a price increase or cost reduction affects total profit. 5. Using multiple what-if parameters for complex scenarios. 5.1. Combine multiple parameters for detailed scenario analysis. Power BI allows you to create multiple what-if parameters, and you can combine them in DAX measures to model more complex scenarios that involve multiple variables, such as changes in pricing, costs, and sales volume. Example: modeling the impact of price and sales volume. You can create two parameters, price increase and sales volume growth, then use both in a DAX measure to calculate adjusted revenue. Adjusted revenue equals sum sales total sales asterisk 1 plus price increase value asterisk 1 plus sales volume growth value. This measure will adjust revenue based on both the price increase and sales volume growth parameters. 5.2. Scenario analysis using multiple slicers. By using multiple slicers for different what-if parameters, you can give users the ability to test various combinations of changes and see the impact on key business metrics. Example: in a budget planning dashboard, you add slicers for sales growth, marketing spend, and operating costs. Users can adjust each parameter to simulate different budget scenarios and instantly see how changes affect the overall budget outcome. 6. Best practices for what-if scenario analysis. 6.1. Clearly define parameters. Ensure that the what-if parameters are clearly defined and labeled, so users understand exactly what they are adjusting. Use descriptive titles and provide explanations where necessary. Example: label your slicers clearly, such as price increase 0% to 10% or discount rate 0% to 50%, to ensure users understand the range and effect of the parameters. 6.2. Use conditional formatting for scenario impact. You can apply conditional formatting to visuals that highlight positive or negative changes based on the scenario. For example, use green to indicate revenue increases and red to indicate revenue decreases. Example: apply conditional formatting to a profit margin table, where positive margin changes are highlighted in green and negative changes in red, helping users quickly identify which scenarios are more profitable. 6.3. Enable sensitivity analysis. By adjusting the increments of your what-if parameters, you can allow users to perform sensitivity analysis to see how small or large changes affect outcomes. Example: for a cost reduction parameter, set small increments, for example, 1%, to enable users to test the sensitivity of profit margins to small changes in cost reductions. 7. Advanced techniques for what-if analysis. 7.1. Use DAX for advanced scenario modeling. Power BI allows you to create more complex scenario analyses using DAX functions. You can use DAX to build calculations that simulate different outcomes based on multiple variables, conditional logic, or historical data trends. Example: profit margin sensitivity. You can use DAX to calculate profit margin sensitivity based on multiple what-if parameters like price changes. Use clustering, forecasting, and outlier detection in Power BI visuals. Deep dive tutorial. Use clustering, forecasting, and outlier detection in Power BI visuals. Clustering, forecasting, and outlier detection are advanced analytics tools in Power BI that allow you to gain deeper insights from your data. These features can help identify patterns, predict future trends, and detect anomalies in your data. In this tutorial, we will explore how to implement clustering, forecasting, and outlier detection in Power BI to enhance your reports and provide actionable insights. 1. Using clustering for pattern detection. 1.1. What is clustering? Clustering is a machine learning technique that groups data points with similar characteristics into clusters. In Power BI, clustering can help you identify natural groupings in your data, such as customer segments, product categories, or regions with similar sales performance. 1.2. Common use cases for clustering. Customer segmentation. Group customers based on purchasing behavior or demographics to target specific segments for marketing. Product categorization. Identify products that sell similarly based on features like price, sales volume, or category. Sales regions. Group sales regions based on similar performance metrics, such as revenue or profit margin. 2. Steps to implement clustering in Power BI. Step 1. Open Power BI Desktop and create a visual. 1. In Power BI Desktop, open the report where you want to perform clustering. 2. Select a visual that represents the data you want to cluster, such as a scatter chart or line chart. Step 2. Enable clustering. 1. In the Visualizations pane, select the visual, for example, scatter chart that you want to cluster. 2. Click the ellipses, 3 dots in the top right corner of the visual, and select Automatically Find Clusters. Step 3. Configure clustering settings. 1. In the clustering dialog box, Power BI will suggest an optimal number of clusters based on the data. You can either accept this number or manually specify the number of clusters you want. 2. Once you confirm, Power BI will generate a new field called cluster, which you can use to visualize the data. Step 4. Visualize clusters. 1. Power BI will assign data points to clusters and color them accordingly in the visual. 2. You can use the cluster field in other visuals, for example, tables, bar charts, to analyze the characteristics of each cluster. Example, in a sales dashboard, you use clustering on a scatter plot of customer spending versus customer age. Power BI groups customers into different clusters based on their spending habits and age, helping you identify high-value customer segments for targeted marketing. 3. Using forecasting for trend prediction. 3.1. What is forecasting? Forecasting in Power BI is an analytics technique used to predict future data points based on historical trends. Power BI uses machine learning algorithms to model time series data and generate forecasts, which can help in budgeting, sales projections, and inventory management. 3.2. Common use cases for forecasting. Sales forecasting. Predict future sales based on historical sales data to plan inventory or adjust marketing strategies. Revenue forecasting. Estimate future revenue trends to aid in financial planning. Demand forecasting. Predict future demand for products or services to optimize supply chain management. 4. Steps to implement forecasting in Power BI. Step 1. Open Power BI Desktop and create a line chart. 1. In Power BI Desktop, open your report and create a line chart to visualize historical data, for example, sales over time, revenue over time. 2. Drag the date or time field into the axis field and the metric you want to forecast, for example, total sales, revenue, into the values field. Step 2. Enable forecasting. 1. Select the line chart visual. 2. Go to the Analytics pane, the magnifying glass icon on the Visualizations pane. 3. Scroll down to the Forecast section and click Add. Step 3. Configure forecast settings. 1. In the forecast settings, define the following. Forecast length. The number of periods, for example, months, quarters, years into the future you want to forecast. Confidence interval. Set the confidence level, for example, 95% to indicate the range of uncertainty in the forecast. Seasonality. If your data has a known periodic pattern, for example, monthly, quarterly, you can set the seasonality manually. If unknown, Power BI can automatically detect it. 2. Click Apply to generate the forecast. Step 4. Visualize the forecast. 1. Power BI will extend the line chart to include forecasted values beyond the historical data. 2. The forecast will include upper and lower confidence intervals, visually represented as shaded areas around the forecast line. Example, in a sales forecasting dashboard, you use forecasting to project next quarter's sales based on historical sales data. Power BI provides a line chart showing the predicted sales trend, along with confidence intervals to reflect the uncertainty in the forecast. 5. Using outlier detection for anomaly detection. 5.1. What is outlier detection? Outlier detection in Power BI identifies data points that deviate significantly from the overall pattern of the dataset. Outliers can indicate potential issues, such as fraud, data entry errors, or unexpected events that require further investigation. 5.2. Common use cases for outlier detection. Sales outliers. Detect unusually high or low sales numbers that may indicate seasonal promotions or data errors. Customer behavior. Identify customers whose purchase patterns deviate from the norm, signaling potential fraud or unique customer needs. Inventory management. Spot abnormal stock levels that could result from miscalculations or supply chain issues. 6. Steps to implement outlier detection in Power BI. Step 1. Create a visual for outlier detection. 1. In Power BI Desktop, create a visual such as a scatter chart, line chart, or bar chart that displays the data where you want to detect outliers. Step 2. Add outlier detection custom visual. Power BI does not have built-in outlier detection in the standard visuals. However, you can use custom visuals from the Power BI Marketplace to enable outlier detection. 1. In the Visualizations pane, click the three dots and select Get More Visuals. 2. Search for outlier detection or anomaly detection in the Marketplace. 3. Import the visual into your report. Step 3. Apply outlier detection. 1. Add the outlier detection visual to your report and drag in the relevant data fields, for example, sales, profit, customer spend. 2. Configure the settings to highlight outliers based on thresholds or deviation from the mean. Step 4. Visualize and analyze outliers. 1. The outlier detection visual will flag data points that deviate significantly from the norm. 2. You can then investigate these anomalies to determine if they represent errors, unusual events, or opportunities for action. Example: in an inventory dashboard, you detect outliers in stock levels using a custom outlier detection visual. This helps identify products with unusually high or low stock levels that may require immediate action to avoid stockouts or overstocking. 7. Combining clustering, forecasting, and outlier detection. 7.1. Integrating advanced analytics techniques. You can combine clustering, forecasting, and outlier detection in the same report to gain a more comprehensive understanding of your data. Each technique provides a different perspective. Clustering helps group data into meaningful segments for comparison. Forecasting predicts future trends based on historical patterns. Outlier detection flags unusual data points for further investigation. Example: in a sales performance report, you use clustering to group customers into segments based on their purchasing behavior, forecasting to predict future sales based on historical trends, outlier detection to flag anomalies in customer spending, such as unusually high or low purchase amounts. 7.2. Best practices for combining these techniques. Start with clustering. Identify natural groupings in your data before applying forecasting or outlier detection. This helps focus the analysis on specific segments. Apply forecasting for future planning. Once you've segmented your data, apply forecasting to predict future trends for each cluster or category. Use outlier detection to ensure data quality. Outlier detection should be used alongside clustering and forecasting to identify potential data issues or unexpected events. 8. Best practices for using clustering, forecasting, and outlier detection. 8.1. Ensure data quality before analysis. Accurate and clean data is crucial for these techniques to work effectively. Ensure that your dataset is well prepared, with no missing values or incorrect data entries, before applying clustering, forecasting, or outlier detection. 8.2. Tailor visuals to your audience. Make sure the visualizations for clustering, forecasting, and outlier detection are intuitive for your audience. Use clear labels, legends, and color coding to ensure that the results are easy to interpret. 8.3. Use confidence intervals in forecasting. Always display confidence intervals when using forecasting, as this helps users understand the potential uncertainty around predictions. It's especially important in decision-making scenarios where forecasts can guide business strategy. Conclusion: by incorporating clustering, forecasting, and outlier detection into your Power BI reports, you can unlock deeper insights from your data and provide users with powerful tools for analysis and decision-making. Clustering helps group similar data points. Forecasting predicts future trends. And outlier detection identifies anomalies that may need further investigation. By combining these techniques, you can enhance the overall analytical power of your reports, helping stakeholders make informed decisions based on accurate, insightful data. Use statistical functions and advanced DAX calculations for in-depth analysis. Deep dive tutorial. Use statistical functions and advanced DAX calculations for in-depth analysis in Power BI. Statistical functions and advanced DAX data analysis expressions calculations are essential tools for performing in-depth analysis in Power BI. These functions allow you to derive complex insights, analyze trends, and create custom metrics that go beyond basic aggregations like sums and averages. In this tutorial, we will explore how to use various statistical functions and advanced DAX techniques to perform deeper data analysis, such as calculating rolling averages, percentiles, rank, variance, and more. 1. Overview of statistical functions in Power BI. 1.1. What are statistical functions? Statistical functions in Power BI allow you to perform mathematical and statistical calculations on your data. These functions help in understanding trends, variability, and the distribution of data. Common statistical functions include mean average, median, standard deviation, variance, percentiles, and more. 1.2. Common use cases for statistical functions. Descriptive analytics. Calculate key statistics like mean, median, mode, and variance to summarize datasets. Trend analysis. Use moving averages or rolling sums to identify trends over time. Rank and percentile calculation. Identify top performers or segment data based on ranking or percentile. 2. Using statistical functions in DAX. 2.1. Descriptive statistics. Mean, median, standard deviation, and variance. 1. Average function mean. The average function returns the arithmetic mean of a column or expression. Average sales equal average sales total sales. 2. Median function. The median function returns the median middle value of a set of numbers. Median sales equal median sales total sales. 3. SaintDev. P in SaintDev. As standard deviation. The SaintDev P function calculates the population standard deviation, while SaintDev as calculates the sample standard deviation. Standard deviation sales equal SaintDev P sales total sales. 4. VAR. P and VAR. As variance. VAR. P computes the population variance, and VAR as computes the sample variance. Variance sales equal VAR. P sales total sales. Example. In a sales performance dashboard, you calculate the average sales, median sales, standard deviation, and variance for total sales over the past year. This helps you understand the variability and central tendency of the sales data. 2.2. Rank and percentile calculations. 1. Rank X function. The rank X function calculates the rank of each value in a column relative to other values in that column, based on a specific measure. Sales rank equal rank X all sales product, total sales, desk, dense. This ranks products based on total sales, with the highest sales ranked first desk. 2. PercentileX, Inc. and PercentileX, EXC functions. The PercentileX, Inc. function calculates the KTH percentile of a set of values, including the first and last values, while PercentileX, EXC excludes the first and last values. 90th percentile sales equal PercentileX, Inc. sales, sales total sales, 0.9. This calculates the 90th percentile of sales data, helping to understand how high-performing products or regions compare to the rest. Example, you use the rank X function to rank product sales and the PercentileX, Inc. function to calculate the 90th percentile of sales. This helps you quickly identify top-performing products and compare them to the broader distribution of sales. 2.3. Moving averages and rolling calculations. Moving averages and rolling calculations are essential for understanding trends over time, especially in sales and financial analysis. 1. Moving average rolling average. You can calculate a moving average using the average X function combined with dates and period to specify the period over which you want to calculate the moving average. 3-month moving average sales equal. Calculate average X sales. Sales total sales. Dates in period date, max date. 3. Month. This calculates a 3-month moving average for sales, smoothing out short-term fluctuations and highlighting longer-term trends. 2. Rolling sum cumulative total. A rolling sum or cumulative total adds up values over a period, such as a running total of sales. Cumulative sales equal. Calculate sum sales total sales. Filter all date. Date less than equal max date. This formula calculates the cumulative sales up to the current date. Example, in a sales trend report, you calculate the 3-month moving average of sales and the cumulative total sales to visualize long-term trends and track the overall progress of sales throughout the year. 2.4. Correlation and regression analysis. While Power BI does not natively support correlation or regression analysis, you can perform some basic correlation calculations using DAX. 1. Correlation coefficient. To calculate the Pearson correlation coefficient between two variables, for example, sales and marketing spend, you can use the following DAX formula. Correlation coefficient equal VAR Crix mean equal average sales, VAR mean equal average marketing spend, VAR numerator equal sum x sales, Crix mean asterisk marketing spend, mean VAR denominator equal SQRT, sum x sales, Crix mean circumflex 2 asterisks, sum x marketing spend, mean circumflex 2, return numerator denominator. This calculates the correlation between sales and marketing spend, providing insights into how closely the two variables are related. 3. Advanced DAX calculations. 3.1. Time intelligence functions. Time intelligence functions in DAX allow you to analyze data over time, such as comparing current period values with previous periods, calculating year-to-date totals, or projecting future trends. 1. Total YTD function. The total YTD function calculates the year-to-date value for a given measure. YTD sales equal total YTD sum sales total sales date. This calculates total sales from the start of the year to the current date. 2. Same period last year function. The same period last year function compares current period data to the same period in the previous year. Sales last year equal calculates sum sales total sales, same period last year date. This helps you compare current sales with sales during the same period last year. 3. Dates YTD function. The dates YTD function returns the dates in the year up to the specified date, useful for cumulative calculations. Year-to-date revenue equal calculates sum sales revenue, dates YTD date. Example, in a financial performance dashboard, you use the total YTD function to calculate year-to-date revenue and the same period last year function to compare current revenue with last year's performance. This provides insights into how the company is performing year over year. 3.2. Conditional calculations with if and switch. You can use conditional logic with if and switch statements to create custom calculations based on specific conditions. 1. If function. The if function allows you to return different values based on a condition. Profit margin category equal. If profit margin 0.2, high, low. This categorizes products or regions based on profit margin, labeling them as high or low profit margin. 2. Switch function. The switch function allows you to evaluate an expression against a list of values and return a result. Sales performance category equal. Switch, true. Total sales 1 million, excellent. Total sales 500,000, good. Total sales 100,000, average, poor. This categorizes sales performance into excellent, good, average, and poor based on total sales. Example, in a product performance dashboard, you use the if function to classify products into high or low profit margin categories. You then use the switch function to categorize sales performance into different tiers, helping decision makers focus on high-performing products. 4. Combining statistical functions and DAX for deep analysis. By combining statistical functions with advanced DAX calculations, you can perform powerful data analysis in Power BI. For example, use rank X to rank products based on total sales and combine it with percentile X Inc. to identify top-performing products. Use moving averages and rolling sums to smooth out trends and gain a better understanding of long-term performance. Apply time intelligence functions to compare current data with historical performance, helping you make informed decisions based on trends and seasonality. Example, in a sales analysis report, you calculate the 3-month moving average for sales, use rank X to rank top-selling products, and apply same period last year to compare current sales with last year's performance. This layered approach provides a comprehensive view of sales trends, top products, and year-over-year growth. 5. Best practices for using statistical functions and advanced DAX. Optimize performance. Advanced DAX calculations can be resource-intensive. Use variables VAR to store intermediate results and reduce redundancy in calculations. Test and validate. Always test your DAX calculations on sample data to ensure that they produce the expected results. Use visuals to interpret results. Combine advanced DAX measures with appropriate visuals, such as bar charts, line charts, and tables, to clearly communicate insights to stakeholders. Conclusion. Using statistical functions and advanced DAX calculations in Power BI enables you to perform detailed and complex analyses of your data. These techniques allow you to go beyond basic aggregations and gain deeper insights into trends, patterns, and variability in your datasets. By applying functions like rank X, percentile X, moving averages, and time intelligence, you can create custom metrics that provide a comprehensive understanding of business performance, helping decision-makers act on data-driven insights. Implement dynamic measures for complex business reporting. Deep dive tutorial. Implement dynamic measures for complex business reporting in Power BI. Dynamic measures in Power BI allow for flexible and adaptable reporting by enabling users to switch between multiple metrics, for example, sales, profit, cost, and calculate results based on user input or selected conditions. Implementing dynamic measures is essential for complex business reporting, where different audiences need to view various key performance indicators (KPIs) on the same report. This tutorial will guide you through creating dynamic measures using DAX data analysis expressions and how to use slicers or parameters to adjust calculations dynamically. 1. Understanding dynamic measures in Power BI 1.1. What are dynamic measures? Dynamic measures allow users to switch between different calculations or metrics in a single visual without needing to create separate reports or visuals for each metric. By combining DAX with user inputs such as slicers or what-if parameters, dynamic measures provide flexibility and interactivity, enabling users to adapt reports to specific needs or conditions. 1.2. Common use cases for dynamic measures. KPI switching. Allow users to switch between different KPIs, for example, revenue, profit, or costs using a slicer. Dynamic time period analysis. Enable users to switch between different time periods, for example, monthly, quarterly, or yearly, and view the relevant metrics for each period. Scenario analysis. Allow users to dynamically choose different scenarios, for example, optimistic, pessimistic, baseline, to adjust the results based on assumptions or external factors. 2. Creating dynamic measures using DAX 2.1. Steps to create dynamic measures with DAX. The most common way to implement dynamic measures in Power BI is by using DAX calculations in combination with slicers or what-if parameters. Here's how you can do it. Step 1. Create a selection table. 1. In Power BI Desktop, start by creating a table that will serve as a selection list for your dynamic measures. This table will contain the options that the user can select, for example, revenue, profit, cost. 2. Go to Enter Data in the ribbon and create a new table with the options you want users to choose from. Measure selection. Revenue, profit. Cost. Name this table measure selection. Step 2. Add a slicer to the report. 1. After creating the measure selection table, add a slicer visual to your report. 2. Drag the measure selection column into the slicer, allowing users to select one of the measure's revenue, profit, cost. Step 3. Create a dynamic measure using switch. Next, create a dynamic measure that changes its value based on the selection made in the slicer. 1. Go to the Modeling tab and select New Measure. 2. Use the switch function in DAX to create the dynamic measure. Selected measure equal. Switch. Selected value. Measure selection. Measure selection. Revenue. Sum sales revenue. Profit. Sum sales profit. Cost. Sum sales cost. Blank. This measure checks which option is selected in the slicer and dynamically calculates the corresponding metric, for example, sum sales revenue, sum sales profit, or sum sales cost. Step 4. Use the dynamic measure in a visual. 1. Add a visual, for example, bar chart, line chart, or card to the report. 2. Drag the selected measure into the values field of the visual. The visual will update dynamically based on the user's selection in the slicer. Example: in a financial dashboard, you create a dynamic measure that switches between total revenue, total profit, and total cost based on the user's selection. When the user selects revenue in the slicer, the visual updates to show total revenue. When they select profit, the visual displays profit instead. 2.2. Best practices for dynamic measures. Clear labeling. Ensure the slicer and visual titles dynamically update to reflect the selected measure, making it clear what metric is currently displayed. Default selection. Set a default selection in the slicer, for example, revenue, to ensure that the report shows meaningful data upon load. Use consistent formatting. Apply consistent formatting, for example, currency, percentage for the dynamic measures to maintain report clarity. 3. Implementing dynamic time period measures. 3.1. Dynamic time period selection. In addition to switching between different metrics, you can allow users to select different time periods, for example, monthly, quarterly, yearly, and dynamically adjust the measure calculations based on the selected time frame. Step 1. Create a time period table. 1. Go to Enter Data and create a table for time periods. Time period. Monthly, quarterly, yearly. Name this table Time Period Selection. Step 2. Add a slicer for time period. 1. Add a slicer visual to your report. 2. Drag the time period field from the time period selection table into the slicer. Step 3. Create a dynamic time period measure. 1. Use the switch function again to create a dynamic time-based measure that changes based on the selected time period. Selected time period measure equal. Switch. Selected value. Time period selection. Time period. Monthly. Calculate sum sales revenue. Dates MTD date. Quarterly. Calculate sum sales revenue. Dates QTD date. Yearly. Calculate sum sales revenue. Dates YTD date. Blank. 2. This measure dynamically calculates the month-to-date MTD, quarter-to-date QTD, or year-to-date YTD revenue based on the user's selection. Step 4. Visualize the time period measure. 1. Add a visual, for example, line chart or bar chart to the report. 2. Drag the selected time period measure into the values field of the visual. 3. The visual will update dynamically based on the time period selected by the user in the slicer. Example: in a revenue analysis report, you implement dynamic time period selection so users can switch between monthly, quarterly, and yearly revenue views. The line chart automatically adjusts to display revenue trends based on the selected time period. 3.2. Best practices for dynamic time periods. Use time intelligence functions. Leverage DAX time intelligence functions like dates MTD, dates QTD, and dates YTD for clean and efficient time-based calculations. Provide context. Clearly label the time period in the visual title, such as revenue monthly or revenue yearly, depending on the selected period. Combine with date slicers. Allow users to further refine the date range by using date slicers alongside dynamic time period selections. 4. Implementing dynamic scenario analysis. 4.1. What is dynamic scenario analysis? Dynamic scenario analysis allows users to adjust input variables, for example, sales growth, pricing changes, or cost adjustments, and see how these changes affect key metrics in real time. By combining what-if parameters with dynamic measures, you can model different business scenarios and their outcomes. Step 1. Create what-if parameters. 1. In Power BI Desktop, go to the Modeling tab and select New Parameter, What-if Parameter. 2. Create parameters for different business scenarios, for example, sales growth. Sales growth parameter 0% to 20% with 1% increments. 3. Power BI will automatically create a slicer for the parameter, allowing users to adjust it dynamically. Step 2. Create a dynamic measure for the scenario. 1. Create a new DAX measure that incorporates the what-if parameter into the calculation. Adjusted sales equals sum sales total sales asterisk 1 plus sales growth value. This measure adjusts total sales based on the selected growth rate from the sales growth parameter. Step 3. Visualize the scenario measure. 1. Add a visual, for example, bar chart or card visual to the report. 2. Drag the adjusted sales measure into the values field. 3. Use the slicer to adjust the sales growth parameter and observe how the visual updates based on the selected growth scenario. Example: in a sales forecast dashboard, you create a dynamic measure that adjusts total sales based on a sales growth what-if parameter. As users adjust the growth rate, for example, from 5% to 15%, the report dynamically updates to show the impact on overall sales projections. 4.2. Best practices for scenario analysis. Use multiple what-if parameters. Combine multiple what-if parameters, for example, asterisk sales. Leverage R or Python visualizations for data analysis optional. Deep dive tutorial. Leverage R or Python visualizations for data analysis in Power BI optional. Power BI supports custom R and Python visualizations, allowing users to extend their data analysis capabilities beyond Power BI's built-in visuals. By integrating R and Python scripts, you can leverage these powerful programming languages to create advanced visualizations, perform statistical analysis, and apply machine learning models. This tutorial will guide you through the process of creating custom R and Python visuals within Power BI, exploring use cases for each, and highlighting best practices for incorporating them into your reports. 1. Setting up R and Python environments in Power BI. 1.1. Installing R and Python. To use R or Python in Power BI, you first need to have R and/or Python installed on your machine. For R, 1. Download and install R from the Comprehensive R Archive Network (CRAN). 2. Optionally, install RStudio, a popular IDE for R. For Python, 1. Download and install Python from the official Python website. 2. Optionally, install a Python IDE such as PyCharm or Jupyter Notebook. 1.2. Configuring R and Python in Power BI. Once R and Python are installed, configure Power BI to recognize these languages. 1. Open Power BI Desktop. 2. Go to File Options and Settings options. 3. Under Global Settings, navigate to the R scripting or Python scripting section. 4. For R scripting, provide the path to the R installation directory. 5. For Python scripting, provide the path to the Python installation directory. Power BI will now be able to run R and Python scripts for visualizations and data analysis. 2. Implementing R visuals in Power BI. 2.1. Using R for data visualization. R offers a vast ecosystem of packages for data visualization, such as ggplot2, Lattice, and Plotly. You can use these libraries to create custom charts that are not available natively in Power BI, or to perform statistical analysis and visualize the results. Steps to create an R visual in Power BI. Step 1. Add an R visual. 1. In Power BI Desktop, navigate to your report. 2. In the Visualizations pane, click the R script visual icon. Step 2. Provide data for the R script. 1. Drag the field you want to use in the R visual from the Fields pane into the Values section of the R visual. 2. Power BI automatically generates a data frame called Dataset based on the selected fields, which can be accessed in your R script. Step 3. Write the R script. 1. In the R script editor, write your R code to generate the visualization. For example, using ggplot2 to create a scatter plot. R library ggplot2, ggplot dataset, A's x equals sales, y equal profit plus, geom underscore point plus, gh title, sales versus profit scatter plot. 2. Once you run the script, the R visual will render the plot in Power BI. Example, in a sales performance report, you use R and ggplot2 to create a scatter plot comparing total sales to profit across different regions. The scatter plot provides a more detailed view of the relationship between these metrics, which helps in identifying underperforming regions. 2.2. Best practices for R visuals in Power BI. Optimize R code. Keep R scripts concise and optimized for performance, especially when dealing with large datasets. Use appropriate libraries. Utilize well-established R packages like ggplot2, Lattice, or Shiny to create interactive and high-quality visuals. Test locally. Before running complex R scripts in Power BI, test them in RStudio to ensure they work as expected and generate the correct outputs. Consider performance impact. R visuals are executed locally, so performance may vary based on the complexity of the script and the size of the dataset. Ensure the script is efficient and optimized. 3. Implementing Python visuals in Power BI. 3.1. Using Python for data visualization. Python is widely used in data analysis and visualization due to its powerful libraries such as Matplotlib, Seaborn, and Plotly. These libraries can be used to create advanced and interactive visualizations or to apply machine learning models directly in Power BI. Steps to create a Python visual in Power BI. Step 1. Add a Python visual. 1. In Power BI Desktop, navigate to your report. 2. In the Visualizations pane, click the Python visual icon. Step 2. Provide data for the Python script. 1. Drag the fields you want to use into the Values section of the Python visual. 2. Power BI generates a Pandas data frame called Dataset from the selected fields, which you can access in your Python script. Step 3. Write the Python script. 1. In the Python script editor, write your Python code to generate the visualization. For example, using Matplotlib to create a bar plot. Python, import Matplotlib, pyplot as PLT, import Seaborn as SNS, hash create bar plot, SNS, barplot x equal dataset category, y equal dataset sales, PLT title sales by category, PLT show. 2. Run the script to render the visual. Example, in a category performance dashboard, you use Python and Seaborn to create a bar chart that visualizes sales by category. This chart is customized using Python's extensive visualization capabilities, providing more control over color schemes, annotations, and interactivity. 3.2. Best practices for Python visuals in Power BI. Leverage Python libraries. Take advantage of Python's powerful visualization libraries like Matplotlib, Seaborn, Plotly, and Bokeh to create detailed and interactive visuals. Ensure code efficiency. Keep Python scripts optimized and simple to avoid performance bottlenecks. Test your code in an IDE like Jupyter Notebook or PyCharm before importing it into Power BI. Use inline visuals. Ensure that the script ends with PL-300, show, or similar commands to display the visual correctly in Power BI. Limit data volume. Power BI only passes the data currently in view filtered data to Python or R, so ensure that large datasets are filtered before using them in Python scripts. 4. Use cases for R and Python visualizations in Power BI. 4.1. Advanced statistical analysis. Both R and Python are powerful tools for performing statistical analysis that goes beyond basic Power BI calculations. You can use libraries like StatsModels Python or LMR to perform regression analysis, hypothesis testing, and more. Example: linear regression in Python. You can use Python to perform linear regression analysis, predicting sales based on advertising spend. Python from Square. Linear underscore model import linear regression. Hash prepare data. X equal dataset advertising spend. Y equal dataset sales. Hash fit the model. Model equal linear regression. Fit X. Y. Hash predict sales. Dataset. Predicted sales equal model. Predict X. Hash plot results. PL-300. Scatter dataset advertising spend. Dataset sales. Color equal blue. PL-300. Plot dataset advertising spend. Dataset predicted sales. Color equal red. PL-300. Title: advertising spend versus sales prediction. PL-300 show. This script uses scikit-learn to fit a linear regression model and plots the actual versus predicted sales. 4.2. Machine learning and predictive modeling. You can use machine learning libraries such as scikit-learn Python or caret-R to build and deploy predictive models within Power BI. Example: customer churn prediction in R. You can use R to build a logistic regression model to predict customer churn. R. Library caret. Model less than train churn tilde. Data equal dataset. Method equal GLM. Family equal binomial. Hash predict churn. Dataset dollar predicted churn less than predict model. Dataset. Plot dataset dollar predicted churn. Dataset dollar churn. 4.3. Custom visualizations. R and Python provide capabilities for custom visualizations that go beyond what Power BI offers natively. For example, you can use Plotly to create interactive 3D visualizations or ggplot2 for aesthetically pleasing statistical plots. Example: interactive 3D plot with Plotly in Python. Python. Import Plotly. Express as px. Fig equal px. Scatter underscore 3D dataset. X equals sales, Y equal profit, Z equal discount, color equal category, Fig show. This script creates a 3D scatter plot that allows users to rotate and explore the data interactively. 5. Best practices for combining R and Python with Power BI. 5.1. Test scripts independently. Before integrating your R or Python scripts into Power BI, test them independently in their respective IDEs. For example, RStudio, Jupyter Notebook, to ensure that the code works as expected and the visualizations are correct. 5.2. Focus on performance optimization. When using R or Python in Power BI, remember that these scripts run locally. To avoid performance issues, ensure your code is optimized for large datasets by filtering data efficiently before passing it into R or Python. 5.3. Leverage Power BI for data cleaning. Power BI's built-in Power Query and DAX features are highly efficient for data preparation. Perform initial data cleaning and transformation in Power BI before passing the data to R or Python for complex analysis or visualization. 5.4. Enhance interactivity with native and custom visuals. Consider combining R or Python visuals with Power BI's native visuals. For example, use Power BI's slicers to filter data that feeds into the R or Python script, creating interactive, responsive visualizations. Conclusion: by leveraging R and Python in Power BI, you can extend your data analysis and visualization capabilities, creating custom charts, performing advanced statistical analysis, and even integrating machine learning models. Whether you're using R for its powerful statistical tools or Python for its flexibility in building custom visualizations, both languages provide opportunities to enhance your Power BI reports with advanced analytics. By following best practices and focusing on performance optimization, you can seamlessly integrate R or Python into Power BI to create more dynamic, insightful reports. Manage Power BI workspace content reports, dashboards, and datasets. Deep dive tutorial. Manage Power BI workspace contents reports, dashboards, and datasets. Managing content within a Power BI workspace is essential for ensuring smooth collaboration, data governance, and efficient reporting. Power BI workspaces act as a hub for organizing reports, dashboards, datasets, and other resources, allowing teams to work together on shared projects. This tutorial will guide you through the process of effectively managing reports, dashboards, and datasets within Power BI workspaces, covering publishing, organizing, sharing, permissions, and best practices for content management. 1. Understanding Power BI workspaces. 1.1. What is a Power BI workspace? A Power BI workspace is a shared environment where you can collaborate with other users to create and manage content such as reports, dashboards, datasets, and data flows. Workspaces are typically used by teams or departments to centralize and manage their analytics assets in Power BI. There are two types of workspaces. My Workspace, a personal workspace available to each Power BI user, suitable for individual use. Shared workspaces, collaborative environments where multiple users can access and work on shared content. These are the most commonly used in organizational settings. 2. Managing reports in Power BI workspaces. 2.1. Publishing reports to a workspace. To share reports with others in your organization, you need to publish them to a workspace. Steps to publish a report to a workspace. 1. Create a report in Power BI Desktop or update an existing one. 2. Once the report is ready, go to the Home tab and click Publish. 3. Choose the workspace where you want to publish the report. If you don't have the necessary permissions for that workspace, you won't be able to publish. 4. After publishing, the report will appear in the selected workspace under the Reports section. Example: you've built a sales performance report in Power BI Desktop and now want to share it with the sales team. You publish the report to the sales team workspace, making it available for other members of the workspace to view and collaborate on. 2.2. Managing reports in a workspace. Once a report is published, you can manage it within the workspace, including renaming, moving, updating, or deleting the report. Steps to manage reports in a workspace. 1. Go to app.power.com and open the workspace where your report is published. 2. Navigate to the Reports section. 3. Use the ellipsis 3 dots next to the report name to access management options. Rename. Change the report's name. Settings. Update report settings, such as permissions, scheduled refresh, and data sources. Delete. Remove the report from the workspace. Download. Download the report as PBIX file to open in Power BI Desktop. Move. Move the report to a different workspace if necessary. Example: after publishing the sales performance report, you realize that the report name isn't descriptive enough. You navigate to the Reports section in the workspace and rename it to Q3 Sales Performance Report for better clarity. 3. Managing dashboards in Power BI workspaces. 3.1. Creating and sharing dashboards. A dashboard in Power BI is a collection of visuals from one or more reports, datasets, or other sources that provide a high-level overview of key metrics. Dashboards are primarily created and managed in Power BI Service app, Power BI. Steps to create a dashboard. 1. In the workspace, click plus New Dashboard. 2. Give the dashboard a descriptive name, for example, Sales Overview Dashboard. 3. You can pin visuals from different reports or datasets to this dashboard. Open a report, hover over the visual you want to pin, and click the pin icon. Choose whether to pin the visual to an existing dashboard or create a new one. Steps to share a dashboard. 1. Once the dashboard is created, navigate to it in the workspace. 2. In the top right corner, click Share. 3. Enter the email addresses of the users you want to share the dashboard with. 4. Set appropriate permissions, for example. Allow recipients to reshare the dashboard or build on the data in the dashboard. 5. Click Share to send the dashboard link to the users. Example: you create a sales overview dashboard that consolidates key visuals from multiple reports, such as sales by region, profit margins, and top products. You then share this dashboard with the sales team and executives, ensuring that everyone has access to critical insights in one place. 3.2. Managing dashboards in a workspace. Dashboards need to be maintained just like reports. You can update, rename, delete, or change settings for dashboards within the workspace. Steps to manage dashboards in a workspace. 1. In the workspace, go to the Dashboard section. 2. Click the ellipsis 3 dots next to a dashboard to manage it. Rename. Update the dashboard name. Settings. Modify dashboard settings, including scheduled refresh, access permissions, and tiles. Delete. Remove the dashboard from the workspace. Add tiles. Manually add new tiles, for example, images, text, or KPIs to the dashboard. Example: after receiving feedback from stakeholders, you decide to update the sales overview dashboard by adding a new KPI tile for revenue growth. You open the dashboard settings and manually add a new tile for this metric. 4. Managing datasets in Power BI workspaces. 4.1. Publishing datasets to a workspace. Datasets in Power BI represent the underlying data that powers reports and dashboards. You can manage datasets within a workspace, ensuring they are kept up to date and accessible to all users. Steps to publish a dataset. 1. When you publish a report from Power BI Desktop, its associated dataset is automatically uploaded to the selected workspace. 2. You can also create datasets directly in Power BI Service using Power Query or importing data from services like Excel, Azure, or SQL Server. Example: you publish a product sales dataset that aggregates data from your company's ERP system. This dataset will be used by multiple reports within the sales workspace. 4.2. Managing datasets in a workspace. Once a dataset is published, it requires management to ensure the data is current and accessible. Power BI provides several features for managing datasets, including refreshing data, setting permissions, and scheduling updates. Steps to manage datasets in a workspace. 1. In the workspace, navigate to the Datasets section. 2. Use the ellipsis 3 dots next to a dataset to access management options. Schedule refresh. Set up automatic data refreshes for datasets connected to external sources. Refresh now. Manually refresh the dataset to pull in the latest data. Settings. Modify dataset settings, such as data source credentials, scheduled refresh times, and permissions. Security. Configure row-level security (RLS) to restrict data access to specific users or groups. Delete. Remove the dataset from the workspace if no longer needed. Example: the product sales dataset needs to be refreshed daily to ensure that the latest sales data is available for analysis. You navigate to the Datasets section, select Schedule Refresh, and set the refresh frequency to every 24 hours. 5. Managing permissions and access in workspaces. 5.1. Setting user roles in a workspace. Power BI allows you to assign different roles to users within a workspace. This controls what actions users can perform on reports, dashboards, and datasets. The available roles are: admin, full control over the workspace, can manage permissions, publish content, and delete items. Member, can edit content, create new reports, and share dashboards. Contributor, can contribute content, for example, reports, datasets, but cannot manage workspace settings or permissions. Viewer can view reports and dashboards, but cannot edit or publish content. Steps to assign or change roles. 1. In the workspace, go to the Settings. 2. Navigate to the Permissions tab. 3. You can add new users and assign them a role, or change the role of existing users. Example, in the Sales workspace, you add a new team member and assign them the contributor role so they can upload datasets and create new reports. You also assign team leads the member role, allowing them to edit and update existing content. 5.2. Managing content access, sharing reports, dashboards, and datasets. You can control who has access to specific reports, dashboards, and datasets within the workspace by sharing the content with users or groups. Steps to share contents. 1. For reports or dashboards, navigate to the report or dashboard you want to share. 2. Click Share and enter the email addresses of users or groups. 3. Set permissions. For example, allow recipients to reshare the content or build reports on the dataset. Example, you share the sales overview dashboard with key stakeholders across the organization, giving them view-only access. You also allow them to reshare the dashboard with other departments that need visibility into sales performance. 6. Best practices for managing Power BI workspaces. 6.1. Organize contents effectively. Use consistent naming conventions. Adopt a consistent naming convention for reports, dashboards, and datasets to ensure clarity and ease of navigation. For example, Q3 sales report or product sales dataset. Create folders or sections. Use different sections within the workspace reports, dashboards, datasets to categorize content appropriately. 6.2. Ensure data governance. Set permissions appropriately. Limit access to sensitive datasets or reports by using appropriate permissions and roles, for example, role-level security. Monitor access. Regularly review who has access to your workspace content and update roles or remove users as necessary. 6.3. Automate data refreshes. Scheduled dataset refreshes. Ensure datasets are regularly updated by setting up scheduled refreshes, particularly for reports and dashboards that rely on up-to-date data. Monitor refresh status. Use the refresh history logs to monitor dataset refreshes and troubleshoot any errors or delays. 6.4. Backup and version control. Download PBIX files. Regularly download reports PBIX files to maintain local backups. Use GitHub or version control. For complex reports or reports with frequent updates, consider using version control systems, for example, GitHub, to track changes. Conclusion: managing Power BI workspace content reports, dashboards, and datasets is key to ensuring smooth collaboration and maintaining data governance within an organization. By effectively publishing, organizing, sharing, and securing content, you can create a structured environment where team members can easily access and work with the analytics resources they need. Following best practices for organizing workspaces, scheduling data refreshes, and managing permissions will help you keep your workspaces efficient, secure, and up to date, ultimately enabling better decision-making across the organization. Deploy content to different environments: development, test, production. Deep dive tutorial. Deploy content to different environments: development, test, production in Power BI. In Power BI, deploying content across development dev, test QA, and production prod environments is essential for ensuring high-quality reports, dashboards, and datasets. This approach enables teams to develop and test solutions in separate environments before releasing them to end users, maintaining data integrity, performance, and security. This tutorial will guide you through the process of structuring, deploying, and managing Power BI content across different environments while adhering to best practices for continuous delivery. 1. Understanding environment management in Power BI. 1.1. What are dev, test, and production environments? Development environment: dev. a workspace where developers can create, modify, and experiment with Power BI reports, dashboards, and datasets. This environment is typically not shared with end users and serves as a sandbox for building and testing new features or reports. Test Environment Test QA, a separate workspace used for quality assurance QA where reports and datasets are tested for functionality, performance, and accuracy. End users do not typically access this environment, but testers ensure everything works as expected before deploying to production. Production Environment Prod, the live environment where final reports, dashboards, and datasets are deployed for use by end users. This environment is optimized for performance and security, with limited access for changes to ensure stability. 2. Structuring workspaces for different environments. 2.1. Setting up workspaces for dev, test, and prod. To deploy Power BI contents across different environments, it's recommended to set up separate workspaces for development, test, and production. Each workspace should be aligned with its respective stage in the deployment process. Steps to set up workspaces. 1. Create a development workspace. Name: Workspace Development. Purpose: for developers to create and experiment with reports, dashboards, and datasets. 2. Create a test workspace. Name: Workspace Test. Purpose: for testers or QA teams to review and validate reports before production deployment. 3. Create a production workspace. Name: Workspace Production. Purpose: the final environment where contents is made available to end users. This workspace should be tightly controlled to avoid unauthorized changes. Example: for a sales reporting solution, you set up 3 workspaces: Sales Reporting Dev, Sales Reporting Test, Sales Reporting Prod. This ensures that reports and datasets go through development, testing, and validation before reaching end users in production. 3. Best practices for deploying content across environments. 3.1. Develop in the dev environment. Start by building your Power BI content reports, datasets, dashboards in the development workspace. Steps for development. 1. Create and test reports. Build and experiment with your reports and dashboards in the dev workspace. Use this environment to test different calculations, visuals, and data sources. 2. Data connections. Use development versions of datasets or data sources to avoid disrupting live production data. 3. Collaboration. Collaborate with other developers in this workspace to iterate on report designs and features. Example: in the Sales Reporting Dev workspace, you build a sales performance dashboard and connect it to a sales development dataset, allowing you to test metrics like sales growth, region performance, and product sales without affecting production data. 3.2. Move to the test environment for validation. After the development phase, you move the content to the test environment for validation. This ensures that the reports and datasets function correctly, perform well, and deliver accurate results. Steps for testing. 1. Publish to test workspace. Once the content is ready in the dev workspace, publish or export the report to the test workspace. 2. Validate functionality. Testers or QA teams review the reports to ensure that all calculations, visuals, and interactions work as expected. 3. Check performance. Run performance checks to ensure that reports load efficiently and datasets refresh without issues. 4. Simulate user access. Simulate different user roles to validate access levels, row-level security RLS, and interactivity. 5. Data validation. Confirm that the data presented in the reports is accurate and up to date. Example: in the Sales Reporting Test workspace, the QA team tests the sales performance dashboard to verify that all metrics are accurate and performance remains optimal when filters and slicers are applied. 3.3. Deploy to production. Once testing is complete, the reports and datasets are deployed to the production environment, making them available to end users. Steps for production deployment. 1. Move content to production. Publish the final, tested version of the report or dataset to the production workspace. 2. Data connections. Update the data connections to point to the production dataset or live data sources. 3. Set permissions. Ensure that only authorized users have access to the prod workspace. Set up specific roles, for example, admin, member, viewer to control who can view or edit the reports and dashboards. 4. Refresh schedules. Set up data refresh schedules for the production datasets to ensure that reports show the latest data. 5. Monitor usage. Once deployed, monitor the usage and performance of the content in production to ensure it meets business needs and performs as expected. Example: in the sales reporting prod workspace, you publish the final sales performance dashboard connected to the live sales dataset. You set up a daily data refresh schedule to ensure the dashboard displays the latest sales figures, and you grant view-only access to executives and sales team members. 4. Deployment methods for Power BI contents. 4.1. Export-import method. The simplest way to deploy content across environments is by exporting reports from one workspace and importing them into another. Steps for exporting and importing. 1. Export from development. In the dev workspace, open the report you want to move. Use the download PBIX option to export the report as PBIX file. 2. Import into test or production. In the test or prod workspace, select Get Data Files, upload your PBIX file to import the report. Example: after completing development in the sales reporting dev workspace, you export the Q3 sales report as PBIX file and import it into the sales reporting test workspace for validation. 4.2. Deployment Pipelines Premium feature. For organizations using Power BI Premium, deployment pipelines provide an automated way to move content through the dev test prod workflow. Deployment pipelines enable smoother and more controlled transitions between environments. Steps to use deployment pipelines. 1. Create a deployment pipeline. In Power BI Service, go to Deployment Pipelines and create a new pipeline. 2. Assign workspaces. Assign workspaces to each stage of the pipeline: development, test, and production. 3. Deploy content. Use the deployment pipeline interface to promote content from dev to test and from test to prod. 4. Compare changes. Deployment pipelines allow you to compare differences between environments before deploying. You can see what has changed, for example, visuals, datasets, parameters, and decide whether to deploy those changes. Example: your organization uses Power BI Premium, so you create a sales reporting deployment pipeline to automatically move reports from development to test and finally to production. This reduces manual steps and ensures consistent deployment processes. 5. Managing data sources and connections across environments. 5.1. Update data sources for each environment. When moving content between environments, ensure that data connections are updated to point to the correct environment's data source, for example, development, test, production. Steps to update data sources. 1. Edit data source settings. In Power BI Service, go to Settings for the dataset or report. Under Data Source Credentials, update the credentials to point to the appropriate environment, for example, switch from the dev database to the prod database. 2. Parameterize connections. Use Power Query parameters to dynamically adjust data source connections based on the environment. This allows you to easily switch between dev, test, and prod data sources without hard-coding connections. Example: in the sales reporting dev workspace, your sales dataset connects to the development sales database. After moving the report to the prod workspace, you update the connection to point to the production sales database. 6. Version control and backup. 6.1. Implement version control for reports. To avoid overwriting important content or losing progress, implement version control for your reports, especially during the development and testing phases. Version control strategies. 1. Local backups. Download and save. PBIX files regularly during development and testing. Label each version clearly, for example, Q3 underscore sales underscore report underscore V10 PBIX. 2. GitHub integration. For more advanced version control, integrate Power BI reports with GitHub or another version control system. This allows you to track changes, roll back to previous versions, and collaborate more effectively with team members. Example, you maintain a version history of the sales performance report by saving each iteration to a GitHub repository. Each version is labeled by date and version number, making it easy to revert to a previous version if needed. 7. Best practices for managing dev test prod workflows. 7.1. Use a consistent workflow. Plan deployment stages. Clearly define when and how contents move between environments, for example, after initial development, before testing, and after testing. Documents changes. Keep detailed documentation on what changes are made at each stage of the deployment to ensure smooth transitions between environments. 7.2. Automate where possible. Leverage pipelines. If you have Power BI Premium, use deployment pipelines to automate content deployment between dev, test, and prod environments. Automate data refreshes. Set up scheduled data refreshes in both the test and prod environments to ensure that datasets always contain up-to-date information. 7.3. Ensure proper governance. Access control. Maintain strict access control for each environment. For example, limit developer access to dev, testers to test, and end users to prod. Monitor performance. Continuously monitor the performance of reports and datasets in the prod environment, making adjustments as necessary to improve speed and reliability. Conclusion. Deploying content to different environments in Power BI ensures that reports, dashboards, and datasets are thoroughly tested and validated before being used by end users. By structuring workspaces for development, test, and production, leveraging tools like deployment pipelines, and managing data connections effectively, you can maintain high-quality, accurate, and secure Power BI solutions. Following these best practices will help you streamline the process, avoid errors, and ensure that your Power BI content is production-ready before reaching its audience.